Hello, everybody. My name is Andrew Orobator, and I am the lead Android engineer at 7 Park Data. So now that you know a little bit about me, let's learn a little bit about you guys. So raise your hand if you write code for a living. Okay, that's a good amount of people. And keep your hands raised. Keep your hands raised. Now, you're only allowed to put your hands down if you've ever written code that crashes. Now, that should be all of you. If there are any hands up, you and I both know that you're lying. So we've all experienced crashes. What do you normally do when you experience a crash? I, for one, go straight to the logcat so I can see the Stacktrace and see what line of code is causing my app to crash. Now, there are 3 possible scenarios when you go to the logcat, which is where your Stacktrace will usually be. The first scenario is easy mode. You're in onCreate view and you forgot to initialize a view, so it ended up being null. You just call find view by ID and you're good to go. The next situation is a little bit harder. You haven't seen this bug before and you're not quite sure how to solve it. So you copy the Stacktrace and you paste it into Google, hoping that the first Stack Overflow result has your answer. The next scenario is mission impossible. This is when you screw up so bad that even the computer doesn't know where you went wrong. The logcat gives you no Stacktrace. Even Stack Overflow can't help you now. Today, I'm going to tell you a story about that third kind of crash. This is Oracle Music Player. I learned Android development just so I could make this app. Some would call it a side project, but I would call it my passion project. Music is something that's very near and dear to my heart, and I had built a music player that played music just the way I wanted it to. I was so close to releasing it to the Play Store, but there was one bug, one show-stopping bug, that I knew that I could not release with. This is Oracle's Now Playing screen. In the middle, front and center, we have a material design card, and that represents the currently playing song. At the top of the card, we have an artist image, and then we have the title of the song, we have the artist, and then the album. And then under that, we have the album art, and below that, we have the playback position. For thousands of my songs, this screen worked perfectly. But there was one song that not only crashed my app, but brought my entire phone to its knees. This is the song Dum Dee Dum by Keys and Crates. Whenever I would play this song, things would seem okay. A few seconds would pass by. I'd be enjoying my music. And then the app turned into an unresponsive mess. Clicking or swiping on any part of the screen gave no response. And my entire phone, not just the app, became incredibly sluggish, if not completely unresponsive. Eventually, the Now Playing screen would just terminate, and I'd be booted back to the previous activity. My immediate reaction upon seeing this crash was to check the logcat to see the Stacktrace and see what line of code was causing my app to crash. I open up the logcat, and I see 2 incredibly unhelpful lines. The first line was from the choreographer. Skip 265 frames. The application may be doing too much work on its main thread. This was just a roundabout way of saying that my app was frozen because screens weren't being rendered, but I already knew my app was freezing, so this wasn't terribly helpful. The next line was from Art, and it read, suspending all threads took 170.488 milliseconds. Thanks again for telling me that my app is frozen. And then the logcat would just clear itself, as if my entire app had just restarted. I had no Stacktrace. I had no idea what line of code was causing my app to crash so badly. I had no error message that I could pass on to the all-knowing Stack Overflow, besides generic system messages, and I knew that wouldn't get me far. This app had over 20,000 lines of code in it, and I wasn't about to go searching through every single one of them to find the bug. Then, I remembered a Google I/O video I had watched about Android Studio's performance monitors. The performance monitors easily allow you to observe the behavior and performance of your application in real time. And it's conveniently located right next to the logcat. The performance monitors give you real-time monitoring for memory, the CPU, the network, and the GPU. The GPU monitor gives you a quick visual representation of how long it took to render the frames of a UI window. It allows you to see how long you took in each stage of the rendering pipeline. In this particular example, we can see that we spent 0.28 milliseconds in the draw phase and 0.04 milliseconds in the measure layout phase. I reproduced the bug, and when I opened up my GPU monitor, it was flat. This didn't really make much sense to me, but I'm guessing that all of the drawing had already been done before I opened the monitor. Either way, this wasn't being too helpful, so I decided to move on to the network monitor. The network monitor allows you to see all of the traffic that your application is generating. It shows you upload speeds and it shows you download speeds, as well as how long it took to transmit that data. I reproduced the bug, and when I opened up my network monitor, I saw 0 kilobytes up and 0 kilobytes down. Nothing to see here. So I moved on to the CPU monitor. As its name suggests, the CPU monitor allows you to see what percentage of CPU time that your app is using. In addition to viewing the CPU usage graph, the CPU monitor also allows for method tracing via the stopwatch icon in the menu bar. This allows you to inspect the call stack and see how long each individual method took to complete. I reproduced the bug, and besides those 2 spikes you see in the beginning from opening up the now playing screen, the CPU monitor was flatlining as well. So I turned to my last hope, the memory monitor. The memory monitor allows you to see how much memory your app is allocating versus how much free memory you have. And when I opened up the memory monitor, I saw a huge spike in memory. It was apparent at this point that I had a memory issue. Although I wasn't throwing an out of memory exception, my app was allocating massive amounts of memory, resulting in unresponsiveness and a soft crash. Now that I knew that I was running into memory issues, I was presented with even more questions. Why am I using so much memory? What's being allocated that's so massive? What can I do to reduce my memory footprint and have a responsive application? Thankfully, the memory monitor comes with a few tools that allowed me to dig a little bit deeper. The first button allows you to enable and disable the monitor, and this is available on all of the performance monitors. The next button, which sort of looks like a garbage truck, allows you to force a garbage collection. This means that the system will reclaim any memory that it sees as unused. Forcing a garbage collection in this case seemed a little hacky, so I decided against using it. The next tool is the Java heap dump. This allows you to see all of the objects in memory. Now, this sounded pretty good, but I decided to check out the last tool just in case. The fourth and final tool is the allocation tracker. It's pretty similar to the Java heap dump because it allows you to see all the objects in memory, but it also tracks which threads are allocating those objects. This sounded perfect. Before I reproduced the crash, I opened up the allocation tracker and I started tracking a little bit before the spike in memory, and I reproduced the crash and I waited until the spike to stop allocation tracking. After several seconds, I was presented with the following screen. Down at the bottom of the screen is a sunburst diagram of all the threads that are in memory. The bigger the circle, the bigger the piece of the pie, the more memory that thread is taking up. At the very bottom of this diagram, there was a thread that was taking up 43% of my app's total memory. Now this had to be where the problem was coming from. The allocation tracker also has a couple of other sections. You have the running threads, and you have the size of the thread, and you can sort by size. I sorted by size, and I saw utils.picasso thread at the very top. Now, Picasso is an image loading library, and there were two images in the now playing screen that were being loaded by Picasso. There was the artist image, and there was the album art. Since the album art was obviously the biggest image on the screen, I removed the album art. I go to play the song Dum De Dum by Keys and Crates, and it still freezes. So I put in the album art and I remove the artist image. It plays for a couple seconds more, and then it reaches all the way to the end of the song. This is great because my app isn't crashing, but I don't have an artist image anymore. So the first thing that I decided to do was figure out how big was this artist image because it was crashing my app so badly. I go to Last.fm, which is where the image is coming from, and to my horror, this image is truly massive. 3600 by 5400 pixels. So let's do some math here to figure out how big this image actually was versus how big it actually needed to be. 3600 pixels times 5400 pixels is going to give you around 19 million pixels. When you're loading a bitmap into memory in Android, the default configuration is ARGB, and that means you get 4 bytes per pixel. 19 million pixels times 4 bytes per pixel is going to give you around 78 megabytes, which is around what the memory monitor was showing when I was crashing my app. So how big did it actually need to be? Well, the artist image was 50 dip square, and on my Nexus 6P, this translated to around 150 pixels square, or 90 kilobytes. It needed to be 90 kilobytes. I was using 78 megabytes. That means that it was almost 1,000 times the resolution that it needed to be at. Now that I understood the problem, I attacked it from two sides. So Last.fm was giving me this massive artist image. So I just asked for a smaller one, and I was good to go. To prevent this problem from ever popping up again, I resized the image with Picasso.fit. This means that the image would always be displayed at the resolution that it needed to be at, the size of the image view. So the main takeaways from this story is that you should always use the right image size for the resolution that you're displaying it at. For a 150 pixel square image, 19 million pixels was way, way too big. And if the logcat isn't being helpful, perhaps Android Studio's performance monitors can give you some insight into the issue that you're dealing with. Thank you. Does anybody have any questions?
So if you're on Picasso.fit, you're still downloading the entire image.
That's true, but I'm downloading. So I attacked the problem from two sides. So I downloaded a smaller image. So I just asked for a smaller image, and then I also resized it down with Picasso.fit.
But you have no control over other images that they might send you for other albums and artists.
Right, which is why I'm still doing Picasso.fit. So when it loads into memory, I'm not using the entire image.
Okay.
Anyone else?
Behind you.
So I'm a little bit new to Android. So I don't know exactly how image loading works, but 78 megabytes still seems to me like something you should be able to load into memory. Like it's large, but it's not that
It's
large.
very large. So on more performant devices with a lot more RAM, it won't be that big of an issue, but the Nexus 6P isn't exactly a small tier phone. It was a flagship when it was released, and 78 megabytes still caused this app to crash. So you definitely want to be very careful with the sizes of the images that you're loading. And also, you're just wasting memory unnecessarily because the image didn't even need to be that big in the first place.
Have you found yourself starting to use these performance monitors regularly now? Because one thing I thought about from here is like, what if you had never listened to that song? I mean, this could have been a nightmare, so it's almost kind of lucky that you did. But do you make this, I guess the question is like, have you now turned this into like a regular part of your build process to look for certain spikes in memory or CPU usage? Or
I don't know about build process, but I definitely have used it more than once. It's more like a checkup process, really. So if anything is seeming a little bit off, I'll just watch the performance monitors for a little bit. Hopefully they're all static. If I see any one of them spiking, then I know what to look into.
When you were trying to figure out which image was causing the problem, in the memory allocation, Android Studio has this really cool thing where you can right-click and say Show Bitmap.
Oh, huh.
Yeah, because for a long time I was like using the old Eclipse tool to go through the heap and like try to find out which bitmap was causing this issue for like a thumbnail scrubbing problem. But in Android Studio, they added this, I guess, in the last 6 months or so. You can just go to the bitmap in memory, right-click and say Show Bitmap, and then you know exactly which image is causing the problem. Cool. Yeah.
Yeah. Luckily, I only had 2 to search for, so it wasn't that bad.
Yeah.
Are there any other questions? We have one over here. Oh, we want the microphone to pick it up.
I joined a little late, but does the memory allocation account for garbage collection? So when you see a large thread using a lot of memory, how would you know you're not looking at a garbage collection issue as opposed to like a large resource being used?
So you're worried about like the garbage collector, like
giving false positives that maybe things aren't getting cleaned up.
That could be an issue, but that's not something that I've ever run into. And I guess you could probably just also wait for the garbage collector to finish, because you'll see that the garbage collector is running in the logcat.
Okay. So the allocations would show before garbage collection?
Probably, yeah. And then you can also just sort the threads by size. So you can just see like, oh, if this has like a whole bunch of miscellaneous stuff, like maybe this is the garbage collector running, or you have more tools at your disposal to identify the threads.
Okay, cool, thanks.
Is there a question over there?
If I use a library, for example, third-party library, is there any way I can, use the performance monitor to look at what's wrong in the library?
Sure. So the performance monitors, as long as you're using a debug build of your app, the performance monitors, like, it doesn't really matter what code is running. It just looks at the device specs. So it's pretty much code agnostic when you see all of those like little spikes in the monitors. So a third-party library wouldn't really come into effect. I was using a third-party library and it showed up in the memory monitor.
So even if it's a native code, that's still fine?
Native code, I'm not 100% sure because it shows running Java threads. I'm not 100% sure how it handles the NDK stuff.
I see. Okay, thanks.
Mm-hmm.
So in your case where you're seeing the app become non-responsive, do you know if there was an actual thread dying or the process was dying, or was it just stuck on processing the image for a very long time? Or
I think what happened is just like it loaded the entire image into memory, and then there was no memory for other threads to run or do anything, so that's why it slowed literally everything down.